Before we can talk about deductive reasoning, we need to go over some definitions. Our first definition we're going to go over is adjacent angles. Adjacent means next to, and if we have adjacent angles, we have two angles that are next to each other. More specifically, they share a vertex and they share a side. In this example, angle 1 and angle 2 are adjacent. They share a vertex and they have one common side. This is an adjacent set of angles. Some common misconceptions. Two angles that share a vertex, like angle 1 and angle 2 in this picture, but have a space in between. Or two angles like this that share a vertex but have some points that overlap. If this is angle 1 and this is angle 2, angle 1 and angle 2 share a vertex, but they overlap, so they are not adjacent. The third misconception is when two angles share a common side but not a common vertex. Angle 1 and angle 2 have a common side, but the vertex is different. These angles are next to each other, but they're not adjacent. A more specific type of adjacent angle is a linear pair. Part of the definition for a linear pair is that the angles have to be adjacent. A linear pair is a pair of adjacent angles where their non-common sides form opposite rays. Well, what does an opposite ray look like? Well, if we have one ray going in this direction, opposite of that ray would be this. So opposite rays really form one line. So if we have adjacent angles where the non-common sides are opposite rays, we're really taking this example and making this ray and this ray a line. Angle 1 and angle 2 form a linear pair. They're adjacent and their non-common side forms a line, forms opposite rays. The third definition, vertical angles. We've talked about vertical being up and down. When we talk about vertical angles, we're using a slightly different definition of vertical. Vertical angles are two angles whose sides form two pairs of opposite rays. Well, we learned that opposite rays really form a line, so if we have two pairs of opposite rays, we really have two lines. Here's one opposite ray. Here's a second opposite ray. We really have two lines intersecting. When two lines intersect, we create 1, 2, 3, 4 angles. Vertical angles are angles that are across from each other in this example. Angle 1 and angle 2 are vertical angles. They share a vertex and their sides form two pairs of opposite rays. These two angles are also vertical, but I'm not going to label them in this picture. Complementary angles. Complement means to complete. Complementary angles complete 90 degrees. Two angles are complementary if, when you put them together, they create 90 degrees. If angle 1 measured to be 40 degrees and angle 2 measured to be 50 degrees, 1 and 2 would be complementary. If I put the two angles next to each other, they would create a right angle. Now be careful, complementary angles don't have to be next to each other. They can be, but 1 and 2 in this picture are complementary. 1 and 2 in this picture are also complementary. Don't think that complementary means next to each other. Supplementary angles are two angles whose sum measures to be 180 degrees. Supplementary also means to complete, to fulfill, but this time we're fulfilling to 180 degrees. Well, what does 180 degrees look like? Well, 180 degrees is a straight line, a straight angle. So supplementary angles are two angles such as 1 and 2, that when I put them together, I get 180 degrees. If angle 1 was 60 degrees and angle 2 was 120 degrees, 1 and 2 would be supplementary. If I put angle 1 and angle 2 adjacent to each other, I would end up with a picture that looks like this. Complementary and supplementary angles are often confused. Here's how I remember it. Complementary forms a corner, 90 degrees. Complementary corner, 90 degrees. Supplementary forms a straight line. Supplementary straight line, 180 degrees. This straight line is a straight angle. It has 180 degrees in its measure. Let's look at a couple postulates and theorems. Postulate 11, the linear pair postulate. We've gone over the definition of a linear pair. A linear pair, two adjacent angles whose non-common sides form opposite rays, whose non-common sides form a line. Well, if you notice, if we combine the linear pair definition and the supplementary definition, by default, linear pairs have to be supplementary. Not all supplementary angles form linear pairs, but all linear pairs are supplementary. So that's what the linear pair postulate says. It's an if-then statement. If two angles form a linear pair, then the two angles are supplementary. When we're writing a proof, if we know that we have a linear pair, we can conclude that the angles are supplementary. If two angles are supplementary, we know that they measure to be 180 degrees. A theorem is a little bit like a postulate, but we have to do a little more proof to figure it out. If we look at vertical angles, angle 1 and this angle form a linear pair. They're supplementary. Angle 2 and this angle also form a linear pair. They're supplementary. So if you think about it, if angle 1 is supplementary to this angle, and angle 2 is supplementary to this angle, angle 1 and angle 2 have to be the same measure. In order for both of these angles to be supplementary to the same angle, 1 and 2 have to be congruent. Since we had to do a little more justification, we can't just write it as a postulate, we have to write it as a theorem. Theorem 2.3, the vertical angles theorem. It's going to be an if-then statement. If two angles are vertical. We know what the definition of vertical angles are. They're angles that are across from each other when two lines intersect. Then the two angles are congruent. In a proof, postulates and theorems are treated exactly the same. There's a slight difference between the two of them, but it's not that big of a difference that we're going to make a huge distinction in this class. One last thing I want to mention about these two. Since these are both if-then statements, I want to talk about the converse. Take a look at the linear pair postulate. If two angles form a linear pair, then they are supplementary. That is true. What about the converse? If two angles are supplementary, then they form a linear pair. If we look at our definition for supplementary angles, two angles that are supplementary might form a linear pair, but they don't have to. Two angles that are just supplementary don't have to be adjacent. If they are, we do get a linear pair. If they're not, they're just supplementary. The converse of the linear pair postulate is not true. It's false. If we look at the vertical angles theorem, if two angles are vertical, then they are congruent. If we look at the converse of that, if two angles are congruent, then the angles are vertical. Well, if we look at our example of vertical angles, that might be true. These two angles are congruent, and they're vertical angles. But we don't have to have vertical angles if all we know is that two angles are congruent. We can have two congruent angles that are in completely different areas. They don't have to necessarily be vertical. The converse of the vertical angles theorem is not true. It's false.